Learning about multiplicative inverse seems a little bit odd at first because when you first learn about it, it's hard to see how it's going to help you. So in this video, I'd like to explain what multiplicative inverse is, but mostly I want to explain how much it helps us when we divide by fractions, which is the module you'll be able to do next after you've done this one. Now, multiplicative inverse just means, well, multiplicative means we're going to do some multiplying. Inverse means the opposite, doesn't it? Now, this refers to fractions. Let's have a look at a fraction, like, for example, a half. If we were to find the multiplicative inverse of 1/2, all that means is, it's also called the reciprocal. Let's write that word down, reciprocal, because you'll come across that from time to time. Now, the reciprocal of any fraction is when you flip it upside down. So if we flip this upside down, we would get 2/1. So half's multiplicative inverse is 2/1, and 2/1's multiplicative inverse is half. Now 2/1, that's really 2 divided by 1. It's just 2, isn't it? And it's worth noting here that if you have a whole number, let's say we have 3, and you say, well, hold on a minute, 3 is not a fraction. Every whole number is a fraction because it's just itself divided by 1, isn't it? So if you wanted to find 3's multiplicative inverse, you write it as a fraction, which means put it over 1, and then flip it upside down, and you'll get 1/3. Now, so what? How do you know that you've definitely found the multiplicative inverse? Well, you can tell it's upside down, but there's a special property that happens when you multiply a number by its multiplicative inverse, and here this is really key, you're multiplying. What do you get? Well, when we're multiplying fractions, and you should know how to do this to have enabled this module, you do the top times the top equals the top, bottom times the bottom equals the bottom. And 2 divided by 2, that's 1. Down here we'd have the same thing, 3 1s are 3, 1 3 is 3. You might know another trick that you can do when you're multiplying fractions. You can do some cancelling sometimes. And you can cancel anything from the top and the bottom or diagonally. Now what cancelling means is you will literally divide top and bottom by a certain number. So I'm going to do that with this one. If I divide this number by 3 and make it 1, and divide this number by 3 and make it 1, I've made the fraction simpler. 1 1 is 1, and 1 1 is 1. 1 divided by 1 is 1. But you can see that if I haven't done that cancelling, 3 1s are 3, and 1 3 is 3. 3 divided by 3, it's still 1. So that's the key to this module, understanding that any number multiplied by its multiplicative inverse, which is its reciprocal, or you might think of it as the flipper of its fraction, you always get 1. Now, lots of people look at this module and say, oh, that was so easy. The answer to every single question is 1. Well, yes, but you need to understand why. You need to understand how to find a number's multiplicative inverse and how to prove that it is its multiplicative inverse by multiplying them together and showing that you get 1. Does it work with any number? Absolutely. Let's imagine 3/4. We'll multiply it by its multiplicative inverse, which would be 4/3. Now, whether you do your cancelling here, divide by 4, divide by 4, divide by 3, divide by 3, 1 1 is 1, 1 1 is 1, 1 divided by 1 is 1. Or if you actually multiplied it out and said 3 4s are 12, 4 3s are 12, 12 divided by 12 is 1, we can see that it works. Now, so what? You might be thinking, I can multiply something by its multiplicative inverse and get 1. Who cares? Well, the reason we need to do this and the reason we want to understand it is because later on when we come to dividing by fractions, we can use this property. Let's take a super easy, and we're now dividing fractions, so you can use this video for the next module, dividing fractions. Now, let's start with something we know like the back of our hand. 8 divided by 2. And if you were explaining that to somebody in about year 1 or 2 who didn't know anything about division or how it worked, you might say this is asking how many 2's there are in 8. We know the answer is 4. Now, this gets a little bit trickier when people say, all right, what is 8 divided by a half? Lots of people see that and they think, oh, that's half of 8, that's 4. But it's not, is it? It's saying how many halves are there in 8. Now, picture 8 pizzas. How many half pizzas are in that? Well, there's 2 half pizzas in this pizza, 2 halves in that one, 2 halves in that one, and you've got 8 pizzas. So you're going to have, that's right, 16 halves in that. Now, you'll notice there's something happening here. 8 2s are actually 16, aren't they? It turns out that if you don't want to do division, you never again have to do it once you know about this, okay? Because there's a trick. If you don't want to do division, you don't have to. You can change it always to a multiplication question. But you've got to do something. You can change divide to times if you make up for it by flipping the thing that you are dividing by, finding its multiplicative inverse and multiplying by that. Now you'll notice if I flip 1 over 2 upside down, I get 2 over 1, which is really just 2, isn't it? And 8 2s are 16, exactly the same answer. So it means that you can take something that was quite a tricky question, we had to think for a minute to think this one through, and you can change it into a real primary school question that's quite straightforward. How do you do it? Well, times and flip. I say times first because you change your division to a times sign. You're still starting with 8, so that doesn't change. But instead of dividing, you multiply. Now let's think about why this works. When we were working out how many halves of a pizza there would be in 8 pizzas, this number was critical, wasn't it? Because we know that there's 2 halves in every one. So we needed to have 2 of them just for one pizza. And then we said, how many pizzas are there? There's 8. So we multiplied by 8. So you can see why it works. Now, to change this around a little bit and think about whether it works all the time, if we had our original question, 8 divided by, was it 4 or 2? 8 divided by 2, let's say. Would it work for that? Now, I just made a pretty big call. I said, if you don't like doing division, you never have to do it again. You can always times and flip. Now, it works with fractions. Will it work with this? Well, yes. Any whole number is a fraction. This is 2 over 1, isn't it? So if we weren't sure how to do 8 divided by 2, I mean, we know the answer's 4. We're just checking it works all the time. Can we multiply and flip? Yes, we can. 8 lots of a half, that's the same as a half of 8. And the answer to both of these questions is 4. So the answer is yes, it works all the time. Now, this makes our life so much easier because we never have to do a tricky question like this and struggle with it, thinking how many 2/3s are there in 6? Now that's kind of a hard question. If you're thinking about your pizzas, you'd be there for a little while. But if you want to change the question, that's times and flip. All right, we know this is really 6 over 1. And we know how to multiply fractions. Top times top equals top. Bottom times bottom equals bottom. Plus, we know that you can do some cancelling if you like, just so that your answer doesn't need to be simplified at the end. Here I can halve the 2 and halve the 6. 3 3s are 9. And 1 1 is 1. I'm not going to write that down. 9 divided by 1. It's still 9, isn't it? So you can take what looks like a tricky question and turn it into a much easier question. And the question, how do you divide fractions? Don't do it. It's tricky. Instead, change the question to a multiplication question. But if you're going to do that, times and flip. That way, if you know how to multiply fractions, you now know how to divide fractions. And you can see the point of the multiplicative inverse, and that flipping a number upside down helps you do something really useful.